Welcome guys to a new episode of path planning using Q-learning, and in this episode we would be building a path planner agent using C++, and we would be using reinforcement learning to solve that issue. So first of all we would have to look at what is reinforcement learning. So I won't go into detail, but reinforcement learning is a subset of machine learning which deals with constructing a reward function for the agent to learn, and it's basically learning by experience. So specifically we would be using Q-learning, that is a reinforcement learning algorithm in our problem, and the algorithm, I've highlighted the algorithm here, and the algorithm just says, and I know that some people don't know about it, so I will be posting some links below so that you can have a better intuition into what's going behind the scenes. But I won't go detail in the algorithm because that itself is will take a couple of videos, but I will just give you a brief overview. For example, let's say that you have a room, right, and it's divided into grids. So let's say this, right? So basically what this formula is saying, that there is a mapping between state and action. For example, what is state? State can be coordinates, state can be anything, velocity, acceleration, state can be anything. So let's say, for example, let's say that state, we have defined state to be the coordinates. So let it be 1 comma 1, 1 comma 2 comma 1, 3 comma 1, 4 comma 1, and 1 comma 2, and so on, right? Let's say our agent is here and the goal is here. So what this algorithm tries to solve is, for every state, that means for every coordinate that the agent is at, so these are the coordinates that the agent can be at. Let me just put my agent here, right? So for every state that the agent can be, we have to find the optimal action, or we have to find the action that maximizes the reward, and this equation helps us do that. All right, so in the end we would be able to code an agent in C++ that is able to find a path to the goal, and the path would be the optimal path to the goal. All right, so that's what we would be going to do. Now Q table is basically a table and can go down, like extend down. So this is the Q table. The Q table, as I told you, is a mapping from state and action. So state can be, in this case, state can be 1 comma 1. Now what is action? So action can be the actions that the agent can take. So I have assumed here that the action that the agent can take is north, south, west, and east. So there will be 4 columns corresponding to the actions. First will be corresponding to north, south, west, and east. So when we instantiate a Q table, we basically instantiate randomly state and action values. So here, let's say I have just instantiated the Q table, so I am just giving random values, right? The algorithm hasn't started yet. So let it be 0.01, 0.03, minus 0.07, 0.05. So this is state, this is action. So next state would be 2 comma 1, and similar minus 0.01, minus 0.05, and so on, right? And the 3 comma 1, 4 comma 1 till n comma n, because assuming it's a square grid. So we did that. Now the algorithm tries to solve this problem by finding the optimal action at each state. So for example, I am at state this state, so this will be about 3 comma 1, sorry 3 comma 2, right? This will be 3 comma 2. So once I'm at 3 comma 2, I will just look at the Q table to decide my next action. So for example, there is a column of 3 comma 2 here, right? So I will go to this column. Let's assume that let it to be a dictionary, right? So it has a key and it has a value. So I will look into the key because I am at this position and I want to find the optimal action to take. And so I will just look at the columns of the actions, and for example, there is 0.07, 1.2, 3.4 and minus 5.6. I will look at each actions that I can take from that state and find the maximum value. So here the maximum value is 3.4. That states that taking west would be the most appropriate action, and that will give me the most rewards in long time. So I will choose that action. So then after taking that action, I will move to another state, that is probably, let's say I move to 3 comma 1. Once I move to 3 comma 1, then I again go to the table and select the key and find the values related to that dictionary, and whatever the highest value is, I will choose that value. So that's how Q table works. And of course there are little other intricate problems, like we also we don't always take the maximum. We sometimes let the agent explore also, but we will see that once we code. So I have made a folder called path planner in Visual Studio Code. Now for this series we would be using OpenCV, but that we would be using at the end. So I won't be going down in this episode installing OpenCV. I would be helping you guys do that in later episodes. So let's make a new file. So first of all, we have to let me name it as main.cpp. Alright, so let me make a new file too and save it as algorithms.hpp, and other file called algorithms.cpp. Alright, so algorithms.hpp would contain the main algorithm of Q table or Q-learning, sorry, and it would be the script that would instantiate the Q table and would contain all the constructor of Q table. So alright, so let's start with making the header file. So let us Q-stream, then include vector because we will be using vector also. And so in Python we can use dictionaries, but in C++ we have map from the STL containers. So yep, then we can use, I think that's all I guess till now. So okay, so first let's make a class called Q-learning. Now once we make the class, let's define the public variables. So for public, I am thinking first of all of a constructor that we have to make so that I can construct the Q table. And now if you think closely, since it's so the thing is that I should put this in the header file. By mistake I didn't, so let me see. there you go. Okay, so first of all, to construct the Q-learning agent, we have to have the state, like the number of states that we would have and the number of actions that we would have, and I guess that is the most things that we would need. And also we would also need how big is the state space. So for example, we would need like let me first code it and then I can give you a better idea. Right. Okay, so here the S stands for the state, like the number of states that we would have. For example, if we are dealing with 2D coordinates, then we will have two states, X and Y, right? So that is something. So that means 2. A means the number of actions that we would have. So for example, if in the example that I showed you, we had 4 actions, north, south, west, east, so this would be 4. And range means the values that the state can take. For example, if the range is 20, if R is 20, then the agent can the states can have value from -10 to 10. All right, so I guess that is all right to understand. So another example, so for example, if I input the range from, for example, I input the range 10, so the coordinates can take value like x like -5 comma -5 till 5 or 4 comma 4, because this, like, there are 10 numbers including between them. So if so, the range will be, the coordinates can take value between -5 to 4. So all right, so we have defined the constructor. Now let's also make a function called Q table logic, and or you can just say it to be, for simplicity, let me all right. So basically Q-table logic is passing the same parameters. So I'm just passing similarly the int s, the state size, the action size, and nn we would discover just now in a moment. Nn is basically range divided by 2. So if the range is 10, so nn will be 5. That means that the values in front of 0 will be till 5 and behind 0 will be till -5. So that is basically, if you plot them in a number line, so the values will lie between -5 to 5. So that is nn. All right, so let's make also a function to print the Q table, because that is also important, and marking it as const because we don't want to change anything. Also, let's make a function called epsilon, get epsilon, that gives us the epsilon value. So epsilon is here. So basically epsilon is how much we want to discover, in the sense that how much we want to take chances and let the agent take random values, take random actions, rather than always take the maximum values. So this is get epsilon. And let me also make a function of void, so void set epsilon, right. Also making a function of get range. So I'm just thinking if it's necessary or not. let's not do that right now. If we need it, we can. So all right, the private variables. So for private variables, we have, first of all, state size. So state size is, as I told you, the x and y. If you're doing in 2D coordinates, then x and y, that means this will be 2. Otherwise, depends on the problem, and it will be set accordingly. So next is action size. So action size is also similar lines. Range is also the same, and I guess let's make a map also now. So we'll be making a map of right now we are assuming that the state coordinates would be integers, and the action values can be float, but that would it's not necessary to be that case, right? But the thing is that since Q table tend to be really large, we always try to work using integers, because there's a reason to it. For example, just let me show you. So for example, suppose you are taking 2 coordinates, x and y, right? And you are saying that the range can be like the range is 20, so x can take values between -10 to 10, and y can take values between -10 to 10, right? So it would be better if I do like this, -10 to 10. So as you can see, the number of values is 20, or approximately 20 times 20. So this itself is 400 of states. Now for 400 states, you have about 4 actions. So as you can see, for only 2 coordinates, the table becomes really large. And for example, if you decide that there are 6 states, right, with 20 values each, so you can imagine it will be, the number of states will be a very large number. And if you decide that you don't want to work with integers but floats, but since Q table works on discrete values, you would have to discretize it, and and that may increase the this number of states in Q table and will take it longer to train. So that is something that you have to keep in mind. So right now I'm just working with integers. You can work with floats by discretizing the state space. It's totally up to you. So I'm also making a boolean flag that I will use it sometime down the road. I'm making a discount variable that I'm putting it as static. Now if you go above, so discount is basically this gamma. So discount basically tells us that how much we want to give weight to our current reward rather than the long-term reward. So if gamma is very less, so we give us all the weights to the short-term rewards rather than giving to the long-term rewards. And if gamma is a huge number, we give a lot of weight to long-term rewards rather than short-term rewards. So that is something that to keep in mind. And I guess if you read the links, you would have a better idea. Let's also just define the number of episodes that so the reason I have defined it as static is because then we can change it from main CPP rather than changing the header file, because it will be visible to the main, it will be a global variable. So let's make, okay, so just putting it as 10, we can change it. The reason I'm defining it as 10 is because With static, if you put const, then you have to give it a value. With const static you have to give a value. With static you don't have to give a value, because if you define a variable as const, that means that it won't change its value, and to do that you have to first give it a value, then only it won't change it. So if you just tell it to be const static and don't give it a value, then it will, like, the compiler doesn't know like what do you want really. So that's why. Okay, oh sorry, float. And we basically also decay the rate of exploration, that is the epsilon. So after each episode we decay the rate, because we want it to explore less and try to exploit more. So that is something. And static tuple, and also learning rate. And I guess if you're familiar with machine learning, it's the same. So learning rate is just how well do you want it, how fast do you want it to learn, rather than how big steps do you want it to take. So I guess that should be enough for our header file. And now let's go in the algorithm CPP file. Okay, so I guess I'm missing one thing. Yeah, so another problem that I guess you won't encounter this problem in Python, but you will encounter in CPP. So as you know, we have to make a Q table, right? So we have to take input from the user. So the user will give input how many states he wants and how many actions he wants, right? And then we have to construct a Q table like this, and essentially it will be a dictionary or a map. But the difficulty in C++ is that since it is a statically typed language, we have to know the size of the table first to allocate the memory, right? There is no easy way to allocate it without getting the inputs from the user. So let me tell you what I'm saying. So for example, let's say the user gives you an input that he wants the state size to be 3, all right, and he wants the action size, so state size to be 3, action size to be 4, and the range to be 20. So that means minus 10 to 10. So now you have to, and this will happen when your program would be running, right, during runtime. So during runtime you have to allocate memory according to the user input. So just making a small Q table. So you have to give value from minus 10 0 0, then minus 9 0 0, minus 8 0 0, so on till the Q table finishes, everything till minus 10, till like 9 9 9, right? But to allocate memory. And for example, the user gives input state 2. Now he gives input state 2. So now you have to allocate a different amount of memory, right? Your memory requirements changes. So that is extremely easy with Python. You just have to make a dictionary, and as it is dynamically typed, it does the work for you. But in C++, you have to come up with tricky ways to do that. Now, as you know, that vector can be allocated during runtime and dynamically. So I will be just making a function that I would explain in just a moment. Okay, so the problem there is the main problem that we have is that as I told you, we can dynamically allocate the vectors, right, of different sizes. We can do this, but how can we do this, right? So for example, if the user inputs the range to be 40, right, then typically you would do this using a for loop, right? And you would have like I would say like for x 1 to, so it was 40, right? So you would just do for x, for example, not taking negative numbers, so x1 to 40 for I is equal, so for I is equal to x1 to 40, and then you will have another nested loop for j is equal to 1 to 40, and another nested loop, and like this. But the thing is that we don't know 40 right now. The user will input that, so how can we can't do this like we can't just do this for I is equal to 1 to n, for j is equal to 1 to n. We can't do this. So we have to find a workaround around this so that we can do this successfully. So the workaround around this is to make a 1D. So for example, so make a 1D vector, and not use for loops, so that this is all these states compressed into a 1D array. Alright, and then after we construct this during runtime, then we know the size, and then we are able to construct it like this. So this is a tricky way to do that, and I guess I will just show you how to do that. So this function tells you that index from multi, and I will just try to explain it. Okay, so now for the algorithms part, I guess we have to just include a couple of things, and also I'm not sure if I want to use it. Let's just see. Include. I guess. Let's see if we need that. We will see if we need that. Alright. So, okay. So first our Q-learing constructor, and okay, Q-learing. Still waiting for it to discover the variables, but for some reason it's not. So alright, let's range out. So it's just trying to setting the private variables to whatever the values the user passes, and alright, so okay, and now body of the constructor. So let's add a try and catch block, because sometimes you could run into errors if the user inputs something that you don't expect. So we are just although yeah, I mean we can do this, okay, and okay, so just printing out if the constructor call was successful or not. And I think just setting the bool flag to be true, and I will just highlight its meaning in some time. So basically this is done, or if this else, you can just throw error -1, and you can just catch it here, and you can just output. So basically it's really important to always make our code error proof or bug proof, because I know that sometimes you think that you can do it after writing your code, but it's like most of the time you won't do that because you would be too lazy to do that. Okay, so we'll make a simple constructor. Now I'm seeing Q-learing. Why is it showing me an error? Oh yeah, so basically I forgot to include the header file, so that's why it was P. There you go. All right, so now it won't show that. It shouldn't show that, but has no one. Okay, that was the reason. Now, yeah, okay. There you go. So this is the constructor. Now let's do the index from multifunction. So let me first write down the function, because then, I'm assuming that you won't. I'm not expecting you to understand it right now. I will explain it. So just trying to just let me do one thing, right? Just let me copy this. Okay, sounds good. Okay, so again, I would just give me a moment so that I can just write down the function. Then I would, like, once I have it on my screen, I would be able to explain it a little better, because then you won't be confused, as you would be having on the whole picture in mind. So this goes. Okay, so what this function is doing is that also, I guess, yeah, so I guess my screen is messing it up, so you can do this. Okay, so what it is doing is that we are basically, so let's say so I would say just give me a moment to just hang on there. Just don't try to understand it if you are not able to understand it. Just give me a moment so that I can also write the Q-learing function. That way you would get the whole picture. So just give me a second. So just right now I'm just coding the Q-learing main function, who would be instantiating the Q table. All right. I think I haven't. Oh, I have. Yeah, so depth is basically the same thing. I've used term depth and breadth because it's easier. Like algorithm wise, we always if we are designing any algorithm or something like that, we always talk in the terms of depth and breadth. So it's the same as state size and action size. So okay. So first, if nn is equal to 0, you have to check it. You can just say standards here. Okay. Another thing that I forgot to tell you was that after this video, like after this series, you'll be able to make something. I'm just finding if I can find the GIF. Okay, I guess this wasn't it. Okay. So let me show you something. So in the end, you'll be able to make something like this. So the agent will start from like this is our suppose a robot and this is a goal position. So it will be start from a position and it will be able to reach the green dot by Q-learning algorithm, and that is how it's a path planning algorithm. So that is something, and I will be also including the link if anyone wants it. So anyone wants the look at the algorithm for. So this is something. Okay. All right. So float size So the thing I told you about constructing a 1D array, so this is how we do that. So basically, as you can see, if we have 4 states, that means the depth is equal to 4 and nn is equal to 10, that means our range is 10. So that means first value can take 10 values, second can take 10 values, third can take 10 values, fourth can take 10 values. So we have 10 raised to the power 4 values. So that is the maximum number of I would say the vector that you have to allocate, or the memory that you have to allocate. So that's what we are doing right now. We are just finding the max index that we will be needing, and after doing that we will just make a for loop. And just allocating a vector. Now I will try to explain what is happening. Okay, the function isn't completed, but now I guess it's a good point to explain what's happening. So basically what we are saying is, so what is happening in this loop is, so for example, let's say the max values, the max index is this. So what's happening inside the loop is, we get the max index here and then we start the loop from here, and suppose first value is I is equal to 0, so it will be passed I is equal to 0, and suppose nn is equal to 10 and depth is equal to 4. So first the function will be called index, let it be index to be short, 0, nn is 10, depth is 4. 0, 10, 4 will be called, okay, and that will be assigned to a vector called key, because we are trying to allocate the key first, that is the state values. So once it goes in this function, this function will be called. And a vector of, as I told you, the vector can be dynamically allocated. It doesn't need to be statically checked. So a vector is allocated and of depth 4, that means of so a vector will be allocated called index will be of 0 0 0 0, 4 zeros. And after that, for I is equal to I to depth, that means the depth is 4, that means the number of state values. So we will basically get index of, first of all, 0 is equal to one dimensional index. So one dimensional index is 0. So 0 0 divide like modulo by nn. So nn here is 10. So as you know, it will be 0. Okay. And now one dimensional index will then go through will be divided by nn. So one dimensional index is 0, and 0 divided by 10 is equal to 0. Okay, then the loop will again go to this state. Now I will be 1, and index of 1 will be equal to one dimensional index divided by 9. So one dimensional index from the previous call was 0. So 0 divided by 10, sorry, 0 modulo by 10. Let me make it a better sign. By 10 is equal to 0, and then one dimensional index, that will be same. Copy, paste, this will be same. So as you can see, after the first call, everything will be 0 0 0 0 0. So now 0 0 0 will be allocated to key, and key will be 0 0 0. Now second times I will be 1, so 1 will be passed here, and then will be same, depth will be same. When I will be 1, one dimensional index will be 1. So 1 modulo by 10 will be 1. So index of 0 will now become 1, and rest will be the same. So as you can see, the next call, the vector will be allocated will be 1 0 0 0. Next I will be 2, so again this function will be called, so again this loop will run, and the index will now become 2 0 0 0. Next call, it will become 3 0 0 0 0, and after it reaches 10, after greater than 10, so then it will become 1 1 0 0 0. So that's how the table will be allocated using this function. And I would recommend you to just go through this once again and try as I described. First putting the value of 0, then 1 and 2, and see what value would be returned. So this is one thing. So continuing, once we have the key, so here we have allocated the key. After that we need to since you can see that the keys would be all positive, right? Because we were allocating everything to be 0, and then we are just dividing, and so if you divide a positive number, you will obviously get a positive number. So we also need the states to be negative. So for that we will just try to normalize it by subtracting size. So size is basically suppose if nn is 10, size will be 5. So right now keys would lie between 0 to 10, but we want it to lie between -5 to 5. So this will take care of that. And after that we want to fill the values for the action. So again we will allocate a vector, but now it will be a float, and let it be breadcrumb. So breadth will be the action size, and we'll just allocate it. So it's always prudent to allocate a vector first, because we don't want any garbage values. So, and we are just putting, let me see, I think I've done something for int. Oh, I see, yeah. So this shouldn't be. So we get the key, but we also have to let me see if everything is fine. So we have got the key value. Okay, so we have to also include math because we are using the power. Okay. X index, we get the index, we get the key values, and for the key values for depth we say, yeah, this is right. This is right. Okay, so once, so yeah, it looks right to me. Okay, so right now we're just giving random values, as I told you. It's basically your choice how like which values to give, but it's always, if you have taken the machine learning course, you must be knowing that it's always good to have a random values. Good values matter a lot. So you can also not like have Gaussian distribution, anything that you think would be suitable for your problem. So right now we're just allocating the key to the value. So Q table was the map. So here Q table was the map. So we're just doing this. No, I'm just seeing why from vector float to allocator float. Okay, so let's see what's the problem here. This is strange. Also going from standard vector float. Oh, let me see here. Standard vector float. I think it looks alright to me, but I don't know why is this showing me. Okay, okay, standard value is float. Oh, we did something stupid. So I think I did this. Yeah, so why is not happening? I don't know. Okay, no problem. So the reason we're using this because there could be like a case when we have instantiated two Q tables and we want their keys and values to be separate. So okay, so that's this, and after this let's make a function to print it because we also want anything to show how a Q table is. Okay. Putting it as constant, and so now we will use the boolean flag. So if init, that means that if the Q table has been allocated. So otherwise we would get a segmentation fault because we are trying to print a Q table which has not been allocated. So sometimes that could waste a lot of time. So it's always wise to put these checks in place. So again, like there are numerous ways to print a map, but yeah, this is one of the ways to do that. You don't have to do this, but yeah, I mean, I'm just doing it. So yep, not and just let me, in case it will fit in the screen. Okay, it has okay. Just using iterators to move through the vectors that we have in the map. So this will give us the keys, and the first one will give the keys, and this iter arrow second will give us the values. So that's how maps are like the standard template library provides us with iterators to access the elements. And for iterator to the keys, we want to get the size of it, like we have the size of it, and we want to print, like give a comma in between the values, right? And let me see, for this is correct. As I guess I'm missing some curly brackets, I will just count them in the end. Okay, the set. So again, it's just a fancy way to print it, but you don't have to do this. It's just something that is a little visually appealing, and it's sometimes important, but to be honest, there's not much that you can do with looking at a Q table, because it's so large most of the times. Of course, it doesn't have to be, but so right now we're just looping through the values, or like you can assume the dictionary values, or in the C++ language it's map. So just closing it. So right now we are just looped through all the keys, like we get a key, iterated to the key, and to the key iterated to the first value or the first row of the Q table, and for the first row we have the key, and we have the, oh, this is wrong. Yep. We have the value. So this is what we are doing. Otherwise not. Oh yeah. So yeah, that's something that. Okay. See out. This is done. Now just gotta check. So first this gotta do it. Oh no, this has, right? Okay, so let me see. This has this. This has. Okay, this looks good. This looks good. This also looks good. Okay, so we have all the curly braces. We just need one thing, and if it is not initialized, we just gotta log in an error that Q-table not initialized. Again, you don't have to do this, but initialized, I guess I've spelled it right. Okay. After this, just setting few functions. Get epsilon, and as you knew it was constant, now just return epsilon. Where is epsilon? Oh, there's no epsilon. I'm not sure if we have allocated epsilon. No, yeah, we haven't allocated epsilon, that's why. So yep, to just looks good. Now we won't have this problem. Return epsilon. Okay. Moving on. Let's also make a setting function that will set epsilon. Okay, what? Just copy. Let me be a person who promotes shortcuts and just copy it. Set epsilon. And we'll have a float e value. Now again, this code, I won't say it's optimized. There are a few modifications for it to be like good code, because I'm just giving it as a tutorial. So, but the next time I would try to optimize it, and you can also see the GitHub link for the code if you want to just dig into it and just do your own stuff. After this episode, you will be able to construct the Q-table, and you can also do your own stuff. You don't have to do what I'm doing, but it's just I'll be just following some of my own work here. So Q. So just now I just remembered that we have to also allocate the static variables. So we're just doing it right now. You can do it from the main loop also, but you have to I'm just initializing it. Okay. And learning rate. So just initializing it with, I would say, okay. All right, let's see what's the error now. Oh, so this was float, right? I guess just do it as float then. Okay, I guess it looks good to me. One thing that I have to do is that Right now, as you can see, I haven't called Qtable logic. So to call this function, you have to pass it through the constructor. So Qtable logic, and passing it range, state size, function size. Okay, I'm just also passing method Qtable generated successfully. Okay. So I guess this marks the end of the construction of the Qtable. Now just let me see if I'm missing something. Okay, just go to main, and so in main we first of all have to include a string. Let me just copy it, stream, and also include not this. Alright, I'll just right now is the test time, so let it be have a state size of 2, range of values I would say 10 to make it small, and action size 4, north, south, west, east, and I would say just q dot, just a simple function that shows the function. Alright, let's do this and see if it compiles or not. Just trying to open my command window. Okay, was like this. This now. So let's see if it compiles. It compiles, right? Okay, so as you could see, I've messed up the formatting. As you can see, the constructor called successful, Qtable generated successfully, Qtable populated with this. Let's figure it out real quick what we did wrong. And yep. Let's see. This looks good. This looks good. Standard C out. This looks good. This looks good. Standard C out. First assignment is 1. Standard C out. Okay. This looks good. That's interesting. Let me see where the problem is. So the problem is Qtable. The problem is with values, right? And there's like always some end line that is being called. So this is alright. Standard C out. This is alright. You gotta catch an end line. Okay. End line, where are you? That's something. Yeah, so that's extremely common, I would say. Debugging your code. So Qtable is. Oh, I guess no, but this. Oh, I guess this. Okay. Let's see. No. Oh, I'm just guessing. Why is that? Why are we getting this? So I guess I did something wrong. I just corrected it in my window. So yeah, so just let me see if it's working like this or not. Okay. Yep, there you go. So yeah, there was some mistake. You can just look at the code right now. So here you can see the Q table instantiated, and as you know that we just gave a random value between 1 to 5 in the action values. So this is the Q table. So just I hope you learned a little bit in this episode of working with maps, vectors, and just simple C++ programming. And if you just like this video, if this video gives any value to you, just give it a like and please subscribe to this channel. I'll be posting the next episode probably next week, and in that we would be making the player class. In total there will be 3 episodes. So this is part 1. Part 2 will come next week, and in part 3 we will build the animation. So thank you guys, and hope you have a nice one.